everyone, welcome to our channel. My name is Rajendra Prasad. Today we discuss about two functions. Today we discuss about two functions. Function chapters. Weightage is 2 plus 2 plus 7, that equal to 11 marks. Function chapter నుండి total గా 2 very short answer, 1 long answer question. Total గా 11 marks దీని యొక్క weightage. మరి ఫంక్షన్స్ లో ఫస్ట్ మనం ఆర్డర్ పేర్ గురించి డిస్కస్ చేద్దాం. ఆర్డర్డ్ పేర్. let a comma b are two sets. A comma b are two sets. A belongs if A belongs to A and B belongs to B, then A comma B is an ordered pair. Let A comma B are two sets. If A belongs to A and B belongs to B, then A comma B is an ordered pair. Here A is called the first component. A is called the first component or coordinate, and B is called the second component or second coordinate. For ordered pair, A comma B. Order pair A comma B. A is called the first component or first coordinate, and B is called the second component or second coordinate of order pair A comma B. For example, A1 B1 and A2 B2 are ordered pairs. Then A1 B1 equal to A2 B2. That implies A1 equal to A2 and A2 equal to A1 equal to A2 and B1 equal to B2. A1 B1 and A2 B2 are two order pairs. Then two order pairs are equal, then the first components are equal and second components are equal. Next, Cartesian product. Cartesian product. Cartesian product. Let A and B are two sets, then set of order pair A comma B such that A belongs to A, B belongs to B is said to be Cartesian product. Cartesian product. If Cartesian product of A and B, of A and B, and it is denoted by A cross B, to be read as A cross B, Let A and B are two sets, set of A comma B such that A belongs to A, B belongs to B. That is set of order pairs is called a Cartesian product. Set of order pairs is called a Cartesian product, and it is denoted by A cross B. For example, A equal to 1, 2, 3 and B equal to x, y. Then A cross B equal to 1x, 1y, 2x, 2y, 3x, 3y. This is A cross B. Number of A cross B equal to 1, 2, 3, 4, 5, 6. Number of A cross B equal to 6. Here B cross A equal to in B x 1, B cross A equal to x comma 1 and x comma 2, x comma 2, x comma 3 and y comma 1, y comma 2, y comma 3. This is B cross A. Here A cross B 1 comma x, 1 comma y, 2 comma x, 2 comma y, 3 comma x, 3 comma y. B cross A equal to x comma 1, x comma 2, x comma 3, y comma 1, y comma 2, y comma 3. Therefore, A cross B is number of B cross A equal to 6. But A cross B is not equal to B cross A. A cross B is not equal to B cross A. If one set of A and B is empty, then A cross B also empty. Next, note if one of the set A, one of the sets A and B, if one of the set A and B is empty, then A cross B is also empty. A cross B also empty. Number of subset of a finite set. number of subsets of finite set equal to 2 power n. Number of proper subsets of finite set equal to 2 power n minus 1. Proper subset means itself, not a itself, that is 2 power n minus 1. Number of A cross B equal to number of A into number of B. Number of subset of A cross B. Number of subsets of A cross B equal to 2 power number of A cross B. 2 power number of A cross B. This formula is very important. We know that natural number is subset to whole number. Whole number is subset to integer. Integer is subset to rational number. Rational number is subset to real number. Real number is subset to complex number. Okay. Natural number is subset to whole number. Whole number subset to integer. Integer subset to rational number. Rational number subset to real number. Real number is subset to complex numbers. We discuss intervals. If A comma B belongs to R and A is less than or equal to B, then open interval A comma B equal to set of X belongs to R such that A is less than X is less than B. Closed interval A comma B. Here X is lies between A and B. Closed interval A comma B. X belongs to R such that A is less than or equal to X is less than or equal to B. Here X equal to A or X equal to B or X is lies between A and B. Closed interval A comma open interval B. X belongs to R such that A is less than or equal to X is less than B. Here X equal to A or X is lies between A and B. Open interval A comma closed interval B. X belongs to R such that A is less than X is less than or equal to B. Here X equal to B or X is lies between A and B. Open interval A comma infinity, that equal to X belongs to R such that X is greater than A. X is greater than A. X value is greater than A. Closed interval A comma open interval infinity, that equal to X belongs to R such that X greater than or equal to A. Here X equal to A and X value is greater than A. Open interval minus infinity comma A, that equal to X belongs to R such that X is less than minus infinity. X is less than A. X value is less than A. Open interval minus infinity comma closed interval A, that equal to X belongs to R such that X is less than or equal to A. These are intervals. These are intervals. Next, relation. Relation. Relation means if A and B are two non-empty sets, if A and B are two non-empty sets, non-empty sets, A and B are two non-empty sets, then any subset of A cross B, then any subset of A cross B is called is called a is called a is called a relation is called a relation. And relation relation from A to B, from A to B. In particular, in particular, any relation from A to A A to A is called a binary relation. Binary is called a binary relation on A. On A. A relation is represented by relation is represented by or A to B or A or B. A or B. Note: if number of A equal to M and number of B equal to N, then the number of relations then the number of relations equal to 2 power mn 2 power mn. For example, A equal to 1 2 3 and B equal to xy. Here A cross B equal to 1x 1y 1 next 2x 2y 3x 3y. Suppose the relation is r equal to 1x 2x 3x is a subset of A cross B. A subset of A cross B is a relation. A relation is a relation. Identity relation. Identity relation. Identity relation. Every element of A is every element of A is related to to itself, related to itself only. Every element of A is related to itself only. That is identity relation. For example, A equal to 1, 2, 3. Relation A to A. Here R equal to 1, 1, 2, 2, 3, 3 is an identity relation. Identity relation on A. Okay. First, types of relations. Types of relations. Types of relations. First, reflexive. Reflexive. Reflexive means A comma A belongs to R for all A belongs to R. This is reflexive. Symmetric. Symmetric. If A comma B belongs to R, then B comma A is belongs to R. Third one, transitive. Transitive. If A comma B belongs to R and B comma C belongs to R, then A comma C is also belongs to R. This is transitive. Anti-symmetric. 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 Anti-symmetric means if A comma B belongs to R and B comma A is belongs to R, that implies A equal to B. This is anti-symmetric. Next, equivalence relation. Equivalence relation. Equivalence relation. A relation a relation is reflexive. A relation is a relation is reflexive, symmetric, and transitive. Then that relation is called equivalence relation. Equivalence relation. A relation is reflexive, symmetric, and transitive. Then that relation is called equivalence relation. For example, R equal to 1, 1, 2, 2, 3, 3, sorry, 3, 3, 6, 6, 9, 9, 12, 12, and 6 comma 12, 3 comma 9, 3 comma 9, 3 comma 12, 3 comma 6. Be a relation, be a relation on the set A equal to 3, 6, 9, 12. The relation is the relation is the relation is reflexive. Reflexive means A comma A belongs to R, for all A belongs to R, and symmetric. Symmetric means it is A comma B belongs to R, then B comma A does not belongs to R, not. And transitive A comma B belongs to R and B comma C belongs to R. That implies A comma C belongs to R. That's right. Here reflexive transitive is possible. Symmetric is not possible. This is relations. Okay. Thank you for watching. Like, share and subscribe.